Okay, in this video what I'm going to do is show you how you can use the JUMP software to find a confidence interval for the population proportion P. We're actually going to do this two ways. What I'll do first is show you how you can use one of the built-in calculators to calculate a confidence interval for P when you're given summary statistics. And then afterwards what we'll do is we'll run to one of the data tables that are built into JUMP. There's one on consumer preferences that polls about 400 people and asks them, everything under the sun. And I'll show you how you could use, JUMP to find a confidence interval using raw data. All right, so what I'm going to do first is go to the week 5 material in Blackboard. And we have a PDF up there for the population proportion. Confidence intervals for the population proportion P. And this is just, my notes that I've constructed for you. But at the end of the notes, there's this example here where the information given to you is summary statistics. In other words, someone ran out and grabbed a bunch of data, asked these people a question, and all we're reporting in the question is how many people we've asked and how many people said yes to our question. All right, so let's give a look. It says, what percent of Nassau County residents will vote for Biff in the upcoming election? Assume that in an unbiased survey of 600 Nassau residents, 317 claimed they would cast their vote for Biff. All right, so the question was asked, hey, you're going to vote for this guy Biff, to 600 people. 317 said, yup, I'm going to do that. So just for the record, if X, which is 317, said yes to the question, out of the 600 people that were asked, remember these together give you the estimate, P hat, which is X divided by N, 317 over 600. So if I crunch that, 317 divided by 600. All right, so the ballpark of about 53% right now said that, yeah, we're going to vote for Biff. So let's write that down as 0.5283, which is 52.83%. So this is the deal. So here's your entire population of Nassau County residents. Here's the N. I don't even know what the population of Nassau County is right now in Long Island, but it's over 1 million, I'm sure of that. So this is pretty large. And the big question is, what is the population proportion of Nassau County residents that vote for Biff? Well, we don't really know that answer, and that's going to be too difficult to get because we don't have the money, time, resource to do that. So remember, what's going on here is we pulled out a small sample of 600, and we got this thing called a statistic called P hat, and we see this is about 0.5283. So the game right now is to use this statistic to estimate the value of the actual population parameter. And, we know that this statistic, now that we found it, it's probably off a little bit from what the true population proportion is, and that's the game. You calculate some error, and you add and subtract this error to this P hat, and what that does is it opens up a window of opportunity, remember, that we call a confidence interval. So I ran through that, and you can see the notes, you could read through it, and I ran through the calculation of the error by hand, the calculation of the standard error, calculation of the error for the confidence interval, and then down here, I actually calculated the confidence interval itself. So you could read through that on your own. What I like to do right now is show you how JUMP will calculate this for you, because remember, in this course, I don't really need to see work like this. We're really involved in the interpretation of these intervals right now, being that we're in an applied class. So if I go to JUMP, remember, we put an add-in in the add-ins menu in the statistical calculators. And I showed you in a prior video confidence interval for one mean. What we're looking at right now is confidence interval for one proportion. All right, so I'm going to select that calculator. All right, the first thing it asks me is it picks your brain and says, what are you going to give me right now? That's what JUMP wants to know. Are you giving me raw data, or are you going to give me summary statistics? All right, well, we have the summarized statistics. In other words, we don't have the actual 600 people with their response. We just know that 600 people were asked and 317 said, yeah, I'm going to vote for Biff. All right, so I'm going to select summary statistics. Nice little window opens up. To be honest with you, the confidence interval calculator is short and sweet. The conditions for the normal approximation are met. The sample size is sufficiently large there. So the number of successes, that's the number of people that said, yeah, I'm going to vote for Biff. And that's 317. And then the sample size, remember, was 600. All right, and the confidence level that was asked of you in a question right here says construct a 95% confidence interval. All right, so as you can see in Jump, they have a spot where you can put the confidence interval in. And then when you click, once you enter the summary statistics here and you click somewhere else, it just automatically crunches the confidence interval for you. So it gives you a couple things, which is kind of nice. It shows you a little graph of the confidence interval where, the lower bound and the upper bound. I know this is a little tiny, but the this little graph right here, the red line on the left is the lower bound of the confidence interval. The red line on the right is the upper bound of the confidence interval. And that blue line in the middle, that's going to be your p-hat. Now, they crunched that for us. The estimated proportion, 0.52833. We already know that. We saw that when we calculated it before by hand. That is the population proportion, the sample proportion, p-hat. The standard error of the portion, 0.03994. That was actually calculated as well, which is right here. I did that by hand, as you can see. So there's your standard error calculation. And here's your lower and upper limits of the confidence interval, 0.48839 and 0.56828. All right, pretty straightforward. And you can see that that is the same answer that was crunched when I did this by hand. All right, so you have the summary statistics. Not such a bad calculation. What if you have raw data, though? That's the big question. All right, so let me go back to Jump. Now, in Jump, there's a bunch of built-in data tables that they've given us, and one of them is called consumer preferences. So what I'm going to do is I'm going to go to the Help menu and go to the Sample Data Library and scroll down to C and find the consumer preferences data file, which is here, consumer preferences. This is also built into your version of Jump. You and I have the same version. All right, so let's give a look at this data. This data set has lots of stuff in it. Again, how many people was it? 448 people were surveyed. Now, the one thing I didn't check on this when I was looking at this data set was if these people were in the same geographic location, and it might say it somewhere in here. Let's just make that assumption. Let's make the assumption that these 448 people are all in the same geographic location. And you can see what's going on here. They have gender, birth year, whether you're single or married, if you have kids, what's your age, how long you've been working at the same employer, position, salary. They have all kinds of stuff. I think they even ask you if you floss and brush your teeth. Yeah, brush after waking up, brush after a meal. Do you floss? Do you brush every day, almost every day, twice a day? Like they have all kinds of data in here. It's kind of an interesting survey. All right, so let's just go back to the beginning and pick something pretty easy. Let's say we're interested in, again, assuming that these people are all from the same geographic location. Let's say we were interested in calculating the population proportion for our area of single parents. I'm just looking at single parents because I could see these two variables sitting right next to one another here, single status and school children. So do you have single status and school children? And the big question I guess we want to know is, hey, what percentage of parents are actually single parents? Now, this is only 448. And if I sort, I think if I right click on here, I could sort here. Let's see. Yep, sort. And I'll sort in ascending fashion. All right, so here's the people that said, yes, I have school-age children. You can see some of them are not single, and some of them are single. It looks to me like the ones that are not single are actually outweighing the single ones, which I think most people would expect. Let's see how many people in our survey said yes to having kids. All right, here we go. All right, right here. 185 people said, yeah, we got kids. And then starting at the 186th person, because remember, I sorted now, they started saying no. All right, so let's say I'm interested in, out of these 185 people, what percentage of them said that we're a single parent? And then can I use that answer, that p hat, to calculate a percentage for the entire population of my area using these 185 people? All right, so the easy way to do that is you go to Analyze, Distribution, and I've shown you this menu already in a prior video. And the Y columns, I am going to put single status in there. Yeah, single status. Oops, let me drag that, hold on. And school-age children, I'll put in the by. And I will say, okay. So, as you can see, it cuts it. In other words, distribution school-age children, yes. In other words, we got school-age children, versus down here, school-age children, no. You know what? I'm not interested in these guys. I'm just interested in the people that say, yeah, I've got school-age children. And then what does it do? It makes you a nice little histogram here of the ones that are not single versus the ones that are single. All right, so, and it gives you a count. 49 of them were single, and 136 of them were not single, for a total of the 185 people that we were talking about. All right, great. So the one thing it doesn't do is it doesn't calculate your confidence interval. So to do that, remember in JUMP, there's these little red triangles. That means you could do more things with this little piece. So if you click on this red triangle right here, and where am I at? Oh, sorry, I got to click on the red triangle right here. So on the single status, I clicked on that little red triangle right there, and you can see one of the options is confidence interval. All right, so I'm going to go ahead and select a 95% confidence interval, and you can see it pops it down here. Now, when you look at this, again, what it does is it just really took this information right here and calculated the confidence interval. Actually, the P hat and Q hat were right here. But as you can see, the percent for single, 49 out of the 185. If you divide those, that gets you your P hat. It did it for us right there, 0.26486. And then what's going on here? The lower and upper bounds. This is 0.2065. Let's, for all intents and purposes, let's call that 21% when you move that decimal to the right. And then right here, let's call this about 33%. So the confidence interval is from 21% to 33%, where the population proportion of single parents for this geographic area would lie. And then obviously it also calculated the confidence interval for the ones that are married, or they just say it as not single, as you can see. Now it would be about 67% to about 79%. All right, so as you can see, calculating confidence intervals for the population proportion, pretty much the same type of thing as it was for calculating confidence intervals for the population mean. Again, you just have to know how to use the statistical calculator, and you have to know how to use this Analyze Distribution menu in JUMP. All right, so I hope this video helped you out. If you have any questions, feel free to shoot me a message on Blackboard. I'll be happy to help you out. Thanks for watching.